Hello, I'm Brian, and I am going to stream about tiger beetle hacking. If you've been here before, you'll know that what we're currently doing is working on the Tiger Beetle Rust client. So Tiger Beetle is a high-speed financial database written in Zig. And it's got clients written in, or it's got clients for use in applications written in Node, Java, other things, Go. It doesn't have one in Rust, though. And so we have some demand to be able to write Tiger Beetle clients in Rust, so I'm working on the code for that. All these Rust clients are actually bindings to an underlying Zig library called TB client. And TB client exposes a CFFI. And so what I'm doing is creating a Rust crate that links to the TB client static library and then presents a idiomatic Rust API. But I've only just gotten started. This is, I think, the fourth time I've streamed, and I'm streaming the whole thing, so I'm not gonna... If you watch the stream, every one of these streams, you'll see the construction of this Rust crate from front to back, all the way through. Not gonna hide anything. And part of this plan is to just show all the mistakes we make while we hack on stuff and figure out what we're trying to do. And I've already made so many mistakes in just a few streams. So I'm excited about that. I love to fail publicly. But eventually we're not going to fail. We're going to get this client written someday. Today, though, let's see. What do I want to do today? I have some plans for today. But first, I think I want to go back and discuss a little bit about what we've done so far. Always got to do a little bit of a recap to catch everybody up. And to do that, let's go over to our code. And what I want to do actually is create a little file to remember what it is we've done. So here's our Tiger Beetle. And in our clients Rust directory, I'm just going to create a markdown file to type notes in about this project. I'm going to call it Tiger Beetle Rust client stuff. And I want to just remember what we've done on a episode by episode basis. And I think we've done 3. And I can use this every time we stream to recap as I forget more and more of what we've done. All right, so the first episode of this stream, we did just setup, project setup. We made a crate. We call it crate setup. And we also kind of sketched Rust API. We read C API and sketched the Rust API based on the C API. And it turns out that that was kind of not worth doing at all. The Rust API we sketched out here, we immediately started breaking that abstraction because we didn't actually know how to use any of the underlying C APIs yet. And the next thing we did in the next episode was, I think we only set up bindgen. Set up bindgen for Rust definitions of C API. And normally I don't use bindgen. I just write things by hand. But it was suggested on stream that we use bindgen for this. And it ended up being a pretty good idea, since just using bindgen is somewhat common and also somewhat advanced Rust thing. So good for doing on stream. And also the Tiger Beetle API is, small and well-designed, easy to automatically analyze for bindgen. But also there are enough definitions there that it would have been tedious to write them all out by hand. So it ended up working out great. Now we have Rust definitions automatically generated that we can just reference every time we need to understand the underlying API. Just burping. All right, I think the last episode we did some exploratory programming to try to understand how the actual TB client API works and how it behaves. Because after reading the API and kind of sketching out an API for Rust on top of it, I didn't fully understand it, especially how the request submission and callbacks work. In the Tiger Beetle client TB client API, it's very simple, but it's callback based, and you submit requests that the submission just immediately succeeds, and then at some point in the future, you get a callback on some other thread because the TB client API hides an event loop inside of it, but that event loop lives on another thread. And so that's what we're binding a Rust Async API to, which means that we're going to end up in this initial version having at least 2 threads going on in Rust, when ideally you don't really want 2 threads for this IO stuff, because it's just going to mean a lot of context switching between threads. But part of this project is to eventually create a pure Rust client, which should be able to eliminate all that overhead. So again, in episode 3, we explored the CTB client behavior, especially the submit function. And at this point, I feel like I understand enough about how TB client works and how it expects you to interoperate with it that I think we can move on. And what I want to do this time is I want to scrap all the code we've written. Of course, that's something that happens a lot in programming. And I want to start over with, based on what I know now, I want to define a ideal async Rust API. This is the API that I think, knowing what I know now, how I want to interact with TB client in Rust. And then implement just an async function, async request for one type of request, which is, I think it's called account lookup. And there's, maybe 6 or so requests in Tiger Beetle. Account lookup is just about the simplest. So I think if we can implement account lookup in a way that seems like idiomatic Rust, that we'll be in a good position to continue and make some real headway on this project. All right, give me a second to just mess with my AV. I'm a little loud in my own cans. I'm annoying myself with my voice. Okay. So we created this little markdown file to keep track of what we've done. I'm going to commit that here. And again, while I'm doing all this kind of exploratory work, I don't really care about my commit history. I always use just a dot as all my commit messages when I'm doing this kind of stuff. I'll worry about the commit history sometime in the future. I do value a nice clean commit history though. And I'll push this and just overwrite all my current branches, my current Rust client branch. And as usual, every time I sit down to start hacking again, I kind of need to recap where I was and kind of catch up. And so what I want to do is I want to rebase onto main and rebuild everything and make sure everything builds. And in fact, I just want to remember how to build this thing right now. So I need to go into the clients directory. And over here, I also need to build the Tiger Beetle CTB client static library, which once again is zig build clients:C, and that's just a custom build target within the Tiger Beetle build script. And then back here, I say in the Rust directory, cargo clean. We'll just start from scratch. and say cargo build. And this should build pretty fast because I got very little code here, very few dependencies. And of course, you'll recall that we have this unfortunate warning about Rust 128-bit integers, which I'm just going to be punting and punting and punting for a long time down the road. Apparently, the Rust 128-bit ints are not ABI stable right now. So that's super ugly. And the Tiger Beetle API requires 128-bit ints. I'm sure it's solvable in some way, though. All right, so now I think I already fetched. I'm going to do a rebase, get rebase origin main, and I'm going to rebuild our C client again. Going to rebuild our Rust client again. I'm going to run, we have a little test program here in the Rust client that mostly just doesn't work, but it should do something. Oh, I don't have a server running, so it's just going to complain. I'll go ahead and start that server. Create another TeamX window here. And this is going to be for running the server. So again, I'm going to say build run start. And I'm just going to have Zig or Tiger Beetle tell me what the command line options to start are. I'm liking my background today. Everything is looking pretty good on stream. I got my new shirt that my partner got for me. It's my favorite current. This is also going to be a fashion stream now, now that I think of it. This is my current favorite textile, which is a blend of cotton and cashmere. And I'm liking the contrast of this dark, dark brown against my orangish warm glow. All right, so Tiger Beetle is telling us we need the addresses argument. And the path to our database. All right, so we're running. And we'll just leave that running forever, probably, for the rest of the stream. And now we can run our client. And okay, it successfully connects and it prints some stuff in the completion callback. So we can get started here. Let me push. Don't know if I pushed or not. All right, so we can get started. And what I want to do real quick before we write any new code, I want to talk about the packet type and all the fields in it in Tiger Beetle or Tiger Beetle client. Because that has been like the big first sticking point in this project is understanding the packet type. The Tiger Beetle client API is pretty simple, but the packet type has a lot of fields and their behavior is undocumented, as far as I can tell. The TB client library is not expected to be used, I think, by anybody except those writing bindings. So it's not documented at all as far as I know. So let's refresh ourselves on, I want to mess with my audio again here. Now I'm too soft in my cans. I want to refresh ourselves on where all the stuff lives that we're going to need to cross-reference while we're coding. So in the Tiger Beetle source client C directory, tbclient.h is the generated C headers, super useful. And in the Rust directory, we have the tbclient.rs, generated Rust definitions, generated from the generated C definitions. And then also in the C directory, we have, what else is important here? tbclient.zig. This is kind of important. This is kind of the entry point to the TB client library, but it's not necessarily presenting a coherent interface that we can read off of. But sometimes when we need to just understand what the library is doing, we need to look here. Then if we look up under the main source directory, there's another thing called TB client exports. This is more important. This is kind of defining exactly which things are exported from the library. But what we want to do here probably is first let's look at tb client.rs and find that packet. I think it's called tb packet t, this thing. So this is the big complicated thing. And let's pull up at least two definitions. This is the Rust definition. Let's also pull up the zig definition, which is in packet.zig. Okay, so these fields should correspond one-to-one with the Rust fields over here. And I've kind of just been speculating about how all this works. I haven't actually looked at any of the other Tiger Beetle client bindings yet to confirm my suspicions. I've just been kind of hacking my way through, reading what the definitions are and kind of making informed assumptions about how everything is supposed to work. And so far that's worked out well. Also sometimes digging directly into the client code to understand what it's doing. This TB packet type, on first glance, it looks, let's look at the zig version over here. It looks a little intimidating, but it's not as intimidating as it looks. So the most important thing here is the operation. This defines what type of request, although in Tiger Beetle it's called an operation, but could also consider it a request, I think. Maybe. Forget that. Forget I said that. Scratch that. This is the Tiger Beetle operation. Like the Tiger Beetle database supports a set of a half dozen or more operations. One of them is the one we talked about before, the account lookup. So this, you got to fill this in with some kind of operation. Status. I don't know what this is, but presumably after the packet comes back to you, the status will be filled out with something. This probably corresponds to like the result. This is like a result of the TB client API. So definitely this is going to be filled out after we get the packet back. In the API, we hand a packet to the client, and then the client calls us back and gives the packet back. I believe that's an ownership transfer. We give ownership to the client gives ownership back to us. So operation status, this data is the most important thing. This is a pointer to the operation, the actual payload of the operation. And then the data size is the size of this pointer, which is interesting. I guess this suggests that this could be variable sized, but the only operation I've looked at, this is constant size. And those are the most important things. The next is this batch stuff. So Tiger Beetle doesn't just send one operation over the wire at a time. That would be very inefficient. Instead, it can send a whole bunch in a single request. And I believe this controls that. So if you make a linked list of packets, according to this batch next, and then turn on batch allowed, then when you submit a packet, Tiger Beetle, the client will run through that linked list and mem copy all those packets into one request, which actually involves mem copying all these data payloads for the operation into one request. This packet is an interesting name because this is not the thing that is sent over the wire. This seems to just be an abstraction between the TB client API and the client bindings. The thing that's sent over the wire is called, I think, a message in TB client. Okay, so that's all of this stuff. For now, my plan is just to ignore batching. I think that's pretty safe. We'll just get it working one packet at a time and think about batching at a later point. This next pointer here is the most mysterious thing. This, I believe, is an internal abstraction used by the client, and I don't have to touch it. Tiger Beetle very frequently uses linked list, like intrusive linked lists, to avoid, creating like growing vectors of things, because Tiger Beetle is very intent on having no dynamic allocation. So instead of like having growable vectors, it'll create just link lists of things and adjust those link lists. And so I think internal to the client, it'll be like storing these packets in a FIFO. There's a common abstraction within the Tiger Beetle code base is these FIFOs of intrusive linked lists. And I think we don't need to touch this. So that's my understanding of how Packet works right now. And I think that's a good enough understanding to really get started on creating a new attempt at what I think the REST API could look like. And I need to really talk to some of the Tiger Beetle experts about this because I know they will have opinions. But it's the weekend right now, and I'm still excited about just doing whatever I want to do. So I'm going to go ahead and create my own abstraction and see how far I can get with that. And then I'll invite them to come critique what I'm doing and tell me what they expect out of a REST Tiger Beetle client. So let me take a refreshing sip of water, check out how the stream stats all look, make sure everything is working correctly, and then we'll get going. I see that somebody's in chat. Hello, Sniper61385. Good to have somebody hanging out with me on a Sunday. We are working on the Tiger Beetle Rust client. And I'm about to get started rewriting all the code I've already written. So this lib.rs file here is everything I have been working on. Plus we have, what is that? Main.rs, where I've been driving it from. And this lib.rs, I initially started by writing this trait. Because again, I want to have two Rust clients for Tiger Beetle. One is going to be the bindings to the C client, which we expect to be inefficient because of it's going to have two underlying event loops. And then another implementation written in pure Rust. So I thought, we'll have a trait and implement that trait two ways. But pretty quickly, I came to understand that I don't understand enough about how the client actually works to bother trying to be that ambitious with defining my abstractions yet. So what I'm going to do is take everything we've already done. I'm going to punt it out to another module called old. And we're going to leave this around just as reference while we are writing the next iteration of this code. And I've forgotten how to indent. Oh, there it is. And then we'll just delete all this stuff. And let's go back to our main here and all this TB. Let's say TB. I kind of want to keep this working. So again, I'm going to call this main old, or at least not working, but compiling, just for a few more minutes until we get our new code working. And again, I'm going to take everything. I'm going to say mod old. And then up here, I'm going to create a brand new function main, just so it'll build. And we're going to see if this builds. Cargo check. Okay. I didn't really say what was wrong here, but moving all that stuff into a module meant that it couldn't find this TB client import anymore. Over here in the library. Why is that? Why is that? Pubmod TB client. Oh, actually, there's more to it than that. So this mod TB client, I moved that inside the old directory. So probably what's going on is the compiler is looking inside a completely different directory, right? So it's looking in a directory called old. So to keep this building, I'm going to take this definition, and this TB client module is our Rust bindings, generated Rust bindings. And here I'll just say use super TB client to make that name available again inside this module. Okay, so that built a library, and now again there's stuff not working here because why? No client in the root, right? So here I said TB, use Tiger Beetle as TB. I'm going to say Tiger Beetle old as TB. This should build again. TB client private module. You pub use. I know I'm fixing these errors really quickly. They're pretty common Rust errors, so I know exactly what it's telling me to do. But by moving, I'll explain this. So it says private module TB client, because what I did was this TB client used to be a module here, but then I made it instead an import of the TB client at the root. But then the code that was expecting to find TB client here can't find this because this is a private import. So I make this as a public import, and all those paths will work again, and this path should resolve. And I was reading a comment on Hacker News the other day. I tend to read the Rust comments stories on Hacker News, and somebody was complaining about how like Rust code is like easy to write but really hard to refactor. And I had to comment like, a big point of Rust design is that it is very easy to refactor. Like you can see, this is an easy refactor to begin with, but I just move stuff around and the compiler tells me exactly what I did wrong and how to get things working again, and now it type checks again. But Rust is intentionally easy to refactor. That's part of its design. Okay, and I'll go ahead and commit this. Oh, I'm feeling worked up about that just talking about it again. Yeah, it's kind of a bad sign that the only times I comment on the internet is when I'm worked up. Okay, so all we've done here now is we moved all the old code out of the way just to keep it building so we can cross-reference it. And now what I want to do is think about the abstraction that I really want for a Rust client. So I'm going to define, it's going to be a struct, and the API is going to be mostly async, but it's a very simple API. And I'm going to need a struct for a client. I'm going to say pub struct client. And I'm not going to tell you what goes inside this client yet, but I'm going to have some methods on the client. And I'm not going to bother defining any traits yet because I learned my lesson from last time, and I know I don't know enough to really define what the final abstractions are, and it's just going to be extra work that I'm going to throw away at some point. And I know we need an init method. And I know we need a dinit method. We're also going to have a drop method because there are resources that need to be cleaned up. But this dinit, we're going to make it possible to handle errors so that you can dinit cleanly. And also, interesting. So I've already said this is called init and dinit because that is what the underlying APIs are called in Zig, but that's not very Rusty. In Rust, we're probably going to call this new and close, because we want to create a Rust API, not a Tiger Beetle API. That's always a tension when you're dealing with like bindings to some other system. Is like, do I use this system's naming or do I use this system's naming? But I feel like my mandate here is to make something Rusty, so that's what I'm going to do. And we know we're going to need impl drop for client. Function drop. And we have new and we have close, and there's not much besides that in the API, but there is one important thing. And let's go look at the Rust bindings first and look at the functions. Let's look at this. So in the Tiger Beetle client API, the thing that really matters here is the submit function. That is almost the entire API. And this submit function submits a packet or a batch of packets to be submitted across the network. And then they're called back on this completion function from the init method. But this submit function is polymorphic. You can submit all kinds of, you can submit about 6 different Tiger Beetle requests using that function. And each of those requests has its own structs that define the request and the response. And this polymorphism, it's a C API, so it's very ad hoc. You just got to cast void pointers around to the correct thing. And that doesn't really make sense in Rust. So this is not the right abstraction for Rust. The obvious thing to me to do is to have a different method for every type of request. So that's what I'm going to do. Another thing you could do is make a polymorphic function in Rust where it's parameterized over the type of request. And that's like something clever, but I don't know. It doesn't make a good looking API in my thinking. So I'm going to say submit. And again, the first request we want to deal with is account lookup. Although one thing to think about is that the API allows batching requests. And if you're batching requests, you could submit many different types of requests in one batch. So if the submit account lookup could string together multiple types of requests into a single batch, then the naming of account lookup wouldn't make any sense. But the way I see this working is that the client, these are going to be async functions. There's going to be a pub async function. Close, probably not async, but this is an async function, right? So the way I think batching will work is the client can call a whole bunch of submits and they get a whole bunch of futures back. And then under the hood, the client code will deal with batching on its own, and the Rust caller won't have to think about batching at all. That makes a lot of sense to me. So you can call submit account lookup, submit transaction lookup, transfer, submit transfer. Just call all those, and then if the client has the opportunity to batch, it will batch. And from the client's perspective, it'll just get a whole bunch of futures back that all look independent, but the actual networking has the batching under the hood. Okay, so I haven't put any return types in here, but I need to. And before I do that, I want to think about what kind of errors we're going to do. And the big choice here right now is whether we want to use the anyhow crate or the this error crate, both of which I have already linked to this crate. These are the two most common ways to define errors in Rust. Rust errors are very expressive and you can define them by hand, but it's a lot of boilerplate, so hardly anybody does. And I think for now, I'm just going to do the simple error handling. I'm going to say use anyhow result. And anyhow defines a existential error type, just one dynamic error type to handle all possible errors, which is very useful for quick prototyping. So these are all going to return a result of something. This result is a type def that says this type can either be an OK of something I define, which is here is the nil type, or the anyhow error type. So implicitly, this is like anyhow error. And I'm going to have all of these return something like that. There's going to be a result of something. But this is actually going to return a future of an account lookup response. And this is going to be a result of probably nil again. And this all might be good enough to type check and see if it builds, except for this. This async function will not type check as it is. We can put macros here to say to do. This drop won't type check. The drop will type check. Oh yeah, the Frank in chat is mentioning some other very interesting Rust error handling crates. There's some very sophisticated ways to handle errors in Rust. You're mentioning the Miet and Eyre crates, EYRE. Those are used a lot by compiler people, especially that want to like accumulate diagnostics and display very sophisticated errors. And I've at some point I've used Miet. I don't think I've used Eyre, but they're very sophisticated, way more than I want to use for this. Those are really good for like I know Nico Matsakis, the compiler engineer, uses them in his Dada compiler for his language he's working on. But very useful for really huge programs that need to accumulate a lot of errors like compilers. But this is going to be a very small program, and we want to be as simple as possible. So I'm going to be using either anyhow or this error. But good point to bring that up. You know, a big point, a big thing about using Rust is kind of understanding all the crates that are available. And something that's kind of lacking in the Rust documentation. Like there's tons and tons of crates and not a lot of attempt to like give new Rust users a guide to the Rust ecosystem, the entire Rust ecosystem, because it's pretty scattered. And people who have been around a long time, used a lot of Rust, you know, kind of have, they understand the roadmap of like, I need to do this, I'm going to go look for this crate. But it's pretty hard, it's pretty overwhelming for new Rust users because it's not just a single place that says, this is the crate to use for this thing. And obvious area of improvement for Rust documentation, and something I am interested in like working on in the future, but it's tough. Like there's a libs.rs site. I think it's libs.rs, maybe it's lib.rs. That kind of started out as like an opinionated source of Rust crates. Like it's a directory to go that is not all inclusive like crates.io, but still libs.rs is overwhelming. Like there's any kind of like community directory has a big tension with like curation and letting people contribute. And I feel like libs.rs is pretty much just as overwhelming as crates.io. Anyway, that's a pretty big tangent. Let's take a drink and regroup. All right, so I want to type check this, but I already know from experience that just putting a to-do in an async function here is not going to type check for complicated reasons. Oh, I'm wrong. This does work. I wonder if that is a recent improvement or if I'm just misremembering the issue here. Just wondering, because usually this is an async function, right? And this to-do, the return type of this is unit, not unit, but bang. It's this type, this never type. And the async function, there's a type system reason why this didn't used to work, but apparently it works now. They must have done some magic here to make these two things type compatible, which is great because it used to be a big pain in the ass that you couldn't just put like a to-do bang in async functions and get it to build. But this seems to be working. All right, I see some more chat. When you are looking at a new library, how do you begin to practice integrating the library into Codebase? Oh, Frank, thank you. All right, chat, you got to remember, this is something that is always happens. I am so bad at switching OBS scenes, so always need people to keep me on my toes about that. I will go for many minutes at a time without showing you the thing I'm actually talking about. So thanks, Frank. So the question about how do you integrate a library into your code base for the first time, this is not a Rust specific question, just a general question. And that's, yeah, Courage is saying I don't have to answer this question, but anyway, I'm cooking now, so I might as well think about it. usually in Rust, I have my own like list of libraries that I'm keeping an eye out on. So I have like a notes. It's like every time I see somebody else using a library, I'm like, oh, that looks pretty neat. And I add it to my list of libraries I might use. I also have a list of libraries I do use. And so I kind of maintain that for my own purposes and potentially for other people's purposes. On GitHub, I have a repo for this specifically called My Rust Lists, Burson/My Rust Lists. I'll type that into chat. And I've been maintaining this for a decade probably. And one of the lists in there is just libraries. I have another one for Rust CLI tools. And so as I'm looking at other people's code, I'll see, oh, they're using this library to do something cool. And I'll write it in my list. And then the next time I am doing something that could use that, I'm like, all right, I'll try out this other library that I've been keeping an eye on for a while. And that is actually literally how I used Miette at some point. I saw that Nico was using Miette in his compiler. And I thought, well, if Nico's using it, it must be the good stuff. That's often what I do as I see coders that are better than me, see what they're doing. And I'm like, all right, let's try to do what they're doing. And it helps that like I have a lot of projects that I start and never finish. So start a new project, be like, all right, I'm going to try using Miette in this project. And then just do it and see how it goes. Oftentimes it ends up, not leading to a new tool in my toolbox. But sometimes it does. Like Miette, I would not use unless I was writing a compiler probably, or something else that had very sophisticated error handling concerns. For example, like I've written, over the years, many web services in Rust, and the best practices for web services are constantly changing in Rust, still not settled. And so I've used a bunch of them. My last project a year or so ago used Rocket. Rocket has had some, problems with its development process over the years. It's just gone very slow, and other projects have passed it by. So I started another web project a month ago, and instead I was like, all right, Axum's the hot thing now. So picked up Axum, and it's always tough, picking up a new library, especially a new framework like Axum. Axum is big. Axum is part of the Tokio ecosystem. And if you're going to use Axum, you got to learn base Tokio. You probably got to learn the hyper crate. You probably got to go find the HTTP crate, the MIME crate. It's all kinds of, there's a bunch of middleware stuff. There's another Tokio project involved called Tower. So if you're using Axum, the Tokio web framework, you're using Axum on top of Tower, on top of Tokio. And ultimately, you got to kind of understand a little bit about all that stuff, which is pretty brutal. But that's kind of my approach to keeping on top of libraries in the Rust ecosystem, at least. Let's go back to doing some of my actual work. And what was I doing? Am I on the right OBS? Yes, I'm on the right OBS. Okay, so this is our client we defined. This, I think, is about sufficient for the number of functions we care about. Even close we don't really care about, but drop is probably going to be like, just defer right to close. Why don't we go ahead and do that since I'm talking about it? So for drop, we're going to say self.close, and these need argument lists still. We're going to say self.close, and we're just going to ignore the potential error because drop has no ability to deal with errors for the most part. And close we'll deal with some other time. And then let's think about new first. And to think about new, let's go back to the old code that we punted down to this old module. Again, if you're just joining us, we are kind of starting over on this Rust client project. All the previous work we've done was, good for understanding, but kind of bleh, not liking where it was heading. So today we're writing a fresh Rust API, kind of my ideal Tiger Beetle client API based on what I know currently about how Tiger Beetle clients work. So previously we had init. Let's look at the implementation down here. Our init function gave a cluster ID, and every Tiger Beetle cluster has an ID. I actually don't understand exactly what it's used for, but it's got to have an ID. Address to connect to. This is actually addresses. This is parsed as multiple addresses in some way that I don't actually currently know. And these are these completion functions. Now, in the real Rust API, which is what we're trying to write now, we're not going to have completion functions. We have async futures. So our new init function, which is now called new to be rusty, we're going to have a cluster ID still. And we're going to have, for now, we're going to still have a string of addresses that'll be parsed under the hood, however Tiger Beetle client parses addresses. But this is not particularly rusty. I have to think about it. This could be like an array of strings or even an array of standard IP adder types. But for now, this is plenty good. It's going to return a new client. And that's it. Like everything else will be handled internally. Then our submit account lookup, let's think a little bit about that too. Well, first let's go finish the close argument list, which is just going to be self. And I think this should probably be mutable. For now, I'm going to pretend that all the methods on client should be mutable just to reflect that they, under the hood, there's definitely mutation happening within the C API. But when you're writing Rust bindings, right, you kind of got to make judgment calls about like what things should be mutable and what shouldn't, because under the hood, you're dealing with a lot of raw pointers. And so your decisions about how your Rust self-references, for example, are mutable or immutable has to kind of be driven, is often driven by just kind of like taste in what you know about the design of Rust APIs, because that might not actually be driven by the internal needs of the type system like it often is with typical safe Rust code. Messing with my mic here. All right, so the count lookup, we're going to have to submit. Let's go look at our submit function again in our old code. So previously we were submitting a packet. And if we look at the packet, again, almost all the details of the packet we're just going to be hiding in our real API. And we can go back to the Zig packet definition. This is our packet again for those just joining us. You know, a big part of what we've done so far is understanding how all of these fields inside this packet work. This is the thing we are submitting to the client. But we're not going to be submitting packets to the Rust client. We're going to submitting on, we're going to call it a request for now, but we got to make sure our terminology is appropriate for Tiger Beetle. But for now, I'm going to call it a request. We're going to say maybe an operation. That is more in line with Tiger Beetle's terminology. We're going to submit an account lookup operation. And we're going to get back an account lookup result or an error. And so internally, this account lookup, submit account lookup is going to handle, you know, construction of this packet and going to handle the polymorphism around this data pointer and this the return pointer within the callback. But from the Rust side, you know, it looks super simple. This also implies that we need some data types here. And I'll go and put them up here by the client data type. Call it account lookup operation. This is a struct. And account lookup result. And this result name here, actually, now that I'm thinking about it, is a little confusing from a Rust perspective, because a Rust result has a very strong meaning. A result is this type, which could be an OK result or an error result. But this, what I'm defining here, is specifically for a success result or an OK result. I might call this account lookup OK. In fact, I just did call it account lookup OK. And this should still type check. Yep, still all looks good. And I'm just going to commit what I got. Now let's think a little bit about filling in these methods. All right, so this client, the whole idea of new is this is going to return a client. The client, for now, is just going to contain a inner client defined by as TB client T, I think is what it is. Yeah. And you can see this is just a pointer to an opaque thing. It's an opaque pointer. We're not allowed to know what a TB client is. And I'm going to call this field TB client. And I'm going to go ahead and say use TB client as TBC, just because I think I'm going to be using this prefix a lot in this code, and I want to make it short and sweet. I could also say, no, this is the thing. I'm going to just give this a different name. I'm going to say TBC, TB client T. And when I call new, we're going to go look at our old code and more or less copy paste what we did here. I note again, there's an init echo function. There's actually two ways to initialize the Tiger Beetle client, and I don't fully understand what init echo does. For now, we're going to be ignoring it. I think it's some kind of testing interface. So new, we're going to do unsafe stuff. And I think I can literally copy paste this and just make a few adjustments. This should be pretty straightforward. Okay, so we create a TB client that is a it's a null pointer. So when we call TB client init, the underlying API, we're passing at a pointer to a pointer, and it's going to fill in this pointer with a pointer to an internal allocation. So it's interesting, the TB client init allocates the client for you, but so far as what I can tell, we allocate the packets, which is kind of unusual for an FFI. Usually you expect there to be clear, like one side of the FFI does all the allocation and all the freeing. But that doesn't seem to be the case here. Of course, it's a small API, so it's not particularly confusing, but interesting to note that the resource allocation policy is a little different depending on the type. As far as I understand so far, that might not be true. So we give it our pointer, cluster ID, address is actually addresses, and we just split that into the pointer and the length. And here I put this really complicated cast here, just because I was demonstrating how to like cast correctly in a previous stream. But I'm just going to use a really simple cast here, because this is infallible. This is not ever going to fail, this cast, but in theory it could fail. So it's fallible, but it's not ever going to fail. You would have to have a very long string that took up more memory than anybody has for this to fail, because we're casting a U size, which is your pointer size, usually 64-bit, to a U32. So it's basically a U64 to a U32. And this on completion callbacks, so this, we're going to be doing something different here. and don't know exactly how we're going to do it, but this is going to be handled internally. Before I was like letting the user deal with the completion callback, but now this Rust client type is going to deal with the completion callback. But I can go ahead and copy at least the definition of the one we used previously down to somewhere, and this will be our completion callback. We could also put this, there's lots of places in Rust where we could define this, but for now I'm going to define it, down here. Could be maybe a little easier to understand if it was closer to the action, like defined within the new method. But for now, I'm just going to drop it down here. And this looks like it'll more or less compile as is. Oh, I remember this code is just completely bogus. Delete it. So before, I was thinking this result pointer and result len, this looks like a string, right? This is not a string. This is another polymorphic type. This is dependent on the type of packet you submit. So not a string at all. But down here I was saying this is definitely a string. So I converted it to a string and printed it. Totally bogus. All right, again, back to our new function. All right, this onCompletion context and onCompletion function. This context, what is this type? It's a usize. So for now, I actually don't understand what this context is intended to be used for. So when you create a client, you give it a context. So one client has one context. And then you can, when you get a callback from that client, it passes you the context. I don't need that, but I think the reason it might do this is so that it's a common pattern in Tiger Beetle clients to create multiple clients, because clients can only have one message in flight at a time. And if you want more than one message in flight, for example, in case like one client has some kind of network problem and the messages are stalled, you can have a second client sending more messages. So in that case, you might use the context to correlate which client the completion is for. And I, in fact, probably need to use that. I'm not sure. I'm not sure if I need to use this or not. I might need this to figure out how to find my particular Rust client type. But you can see the callback also passes us the TB client T, which seems to be sufficient for discovering the client type. All right, Chad, I've got a big problem here. My Bluetooth has stopped working. Forgive me for a moment. I don't know what the deal is with this computer. Don't know what the deal is. So right now I plugged my keyboard into the my Bluetooth keyboard into the computer, and I'm trying to get it to work again. Yeah, something wrong with this computer specifically. Think it's working again. Might be the interaction between this particular Bluetooth keyboard. And it looks like it's working, although now my sound buffers feel like they're messed up in my cans, at least. How's the sound over there for you, Chad? If anybody hears a lot of static, let me know. At least while I was messing around with the Windows system settings, I was hearing static in my cans. Because my sound setup on this streaming computer is very complicated. And I've got some pretty low buffers running between the various applications here. And anytime Windows decides to use its own sound, like I'm using ASIO for all the routing between my streaming applications, but anytime Windows decides to use the regular Windows Media API, whatever it's called, I start hearing static in my headphones. So that's a bummer. Anyway, I'm kind of feeling like I'm losing a lot of steam here, chat, but I've really only gotten started with what I intend to accomplish today. Let's see if we get a little bit more, and then maybe we'll take a break. My audio sounds okay to me, but let me know. I'm paying attention to chat. All right, where were we? The client, we have a TB client here. Oh, this completion callback. We got to figure out what we're doing with this bad boy. So we copied a skeleton completion callback here. And we have an option of using this context to do some kind of correlation between the callback and the client we're using. And this completion callback runs on another thread, but it comes with a packet, and this packet also has room for user data. So I'm not sure whether we're going to care about this context at all. I am curious what other bindings are using the context for, but I am not currently seeing any reason to use it. I'm just going to give it a some kind of recognizable number here, magic number here, in case it ever pops up during debugging. But I think we're not going to use this context. And here's our onCompletion callback. So the idea is that when we submit a packet, the user data of this packet will contain, some data that allows us to get back to our Rust client. All right, so here we've been initted. I think this is all more or less correct. And then we're checking OK or not. This is not Zig client. Now this is called client. And this error case is wrong. But we can say, right now we're using anyhow. And the anyhow provides a macro for creating anyhow errors. And we're just going to say error, anyhow, init error. And we're just going to splat the status right there. And this is not good enough for production, but for now it will type check and compile, hopefully. Submit account lookup. Let's see where we are, see if this all type checks. And again, I'm not actually going to run any code for quite a while. I'm just going to type check stuff and get stuff building. I used some incorrect syntax here for my struct. No C char. Okay, I just need to do some C imports. I think this is std os raw C char. Rust standard library defines a few C types, and that's one of them. Client does not have this field, because I called it TB client. Though now that I think about it, I kind of like client better. I'm going to call that field client. And this said expected result found, semicolon here. Rust compiler tells me I did that wrong. Okay, that type checks. Just gonna commit. And there's a few other warnings here. I'm accumulating warnings. Got a lot of unused stuff, which is perfectly fine by me for now. During all this kind of prototyping phase, I don't care at all about unused. I think I can just put allow unused up here, and then I'll get rid of most of those. Yep. So now we just got our two ominous FFI warnings about 128-bit types. We could even get rid of these warnings for now. I'm less inclined, because these are actual bad warnings. I'm less inclined to just hide those, but kind of don't want to keep explaining them every stream. We'll go back and fix it eventually. So we'll say allow improper C types. And then I'll put a comment here explaining why. U128. Okay. All right, so this all type checks. Again, I don't want to run anything yet. It's pretty common in Rust. You do a lot of type checking, and then a few hours later, you actually try to run things. Let's close. Thinking about whether I want to deal with close yet or just make it a no-op and leak stuff. Kind of just want to do nothing. Kind of want to do nothing for that. All right, because submit account lookup is the meat of this. Okay, let's think a little bit about, actually, I think I want to take a little bit of a break, collect my thoughts, because writing the submit account lookup and dealing with the callback and everything is going to be a big project, a little bit of a project on its own. So chat, I'm going to take a 5-minute break and then let me do my, all right, chat, I'm going to take a 5-minute break and then I'll be back and we'll go figure out how to submit a Tiger Beetle account lookup packet. Thanks for sticking with me. I'll see you in a few minutes. Just jamming a little there. Part of my concept is to do both coding and music. I'm not a particularly skilled musician, though. Hey, thank you, Throat Pies, for welcoming me back. Yep, just doing a little synth solo there as I try to clear my mind from our before the break. I know I've said this every single stream, but streaming while working is so much harder than just working. Gotta write code and think and talk about everything you're thinking. And sometimes you gotta like think about one thing but talk about another thing. And also I'm at a standing desk here, so I have to stand for as long as I'm gonna be hacking, which I think I like, but it's all a little bit taxing. So far, I've only been able to stream for 3 hours max. 1 hour is where I start getting like, oh, this is getting tough. After 3 hours, I had to go like put my head in my hands for like 10 minutes and just be like, I'm so toast. I am so toast. And then you can kind of like normal working, you can take breaks. Streaming working, every time you take a break, you got to think like, am I going to lose everybody? Got to keep it going, keep it going. Anyway, it's good practice. I'm doing this for practice, good public speaking practice, good practice in general. I also think, streaming, I'm a procrastinator, like I have a hard time getting myself to buckle down and do work. And so if I'm streaming, then I got, people paying attention to me that I got to be accountable to. Anyway, I'm really loving, so it's kind of dusk here. And during the day, I got this big window here. So during the day, my backlights are kind of washed out. But during night, I can kind of have whatever beautiful colors I want in the background. And I'm really liking this orange glow I've got going right now. Whew. Oh, hey, Steel Tormentor. Glad you're back. All right, let's think a little bit about the thing we want to do next. So beforehand, we kind of outlined a brand new API for our Rust client. Based on what I think I know about how the Tiger Beetle client works, this is what I want to see in the Rust client, where we have, a client struct. And again, Chad, I'm sorry for not OBSing you to the right scene. Let's go look at the code. So we have our client, and this client, create a new client very simply. And then instead of having a single submit function like the underlying C API, we're going to have a different submit function for every single possible type of Tiger Beetle operation, which makes a lot of sense from the Rust perspective. It's going to be, very type safe, whereas the underlying submit operation is polymorphic. But let's have a single method, a separate method for every single Tiger Beetle operation. And so we're focusing on figuring out how to implement one operation, the account lookup operation, the simplest of Tiger Beetle's operations. And what I want to try to get done before we give up tonight, and I go put my head in my hands for 10 minutes, is to get an account lookup to work using this API. Let's just talk through a bit about how I think this should end up working. And again, let's go look at our packet. The packet is the thing that we're going to submit to the Tiger Beetle client API. And we submit the packet. We're not going to do any batching. The packet comes in this data. This is just a pointer to some packet-specific, operation-specific data. For us, it'll be a U128 that represents the account we're trying to look up. And then let's go look up real quick the TB client. Oops, what is this? Nothing. TB client header file. TB client completion is what I'm looking for. I think there's a definition for it somewhere. Oh, I'm still hearing background music. I'm meant to turn off that background music. There we go. The completion, I think there's a definition of this somewhere that isn't just a bunch of unnamed types. Completion T? Completion, let's just see if completion is used anywhere else here. Nope. TB client.zig, maybe. Completion. Here we go. This is the definition of the completion callback. So we're not going to get any feedback about our packet until we hear back from the completion callback. And so if we go back to packet, we can pass in custom data. Okay, we pass in the packet data or the operation payload through this data pointer. And then I believe we can pass custom data through this user data pointer. And I'm hoping that's what this is for, because we're going to need to pass some kind of custom data in order to look at that data and find our original Rust client context. So we pass in this client data, and then on the completion, we get this result pointer. And again, I was assuming this was a string because this looks very string-like, but this is actually a polymorphic pointer to a struct. Kind of like this data is polymorphic pointer to a struct. It's operation dependent. So based on the operation you submitted, you have to cast this to the correct struct and look at it to understand what happened with the result. And then again, when this completion callback is called on some other thread, and that's not what we really want in Rust. We want our Rust API, which is an async API, to look like everything is happening within the context of a single thread and that single thread's event loop. So my plan here is to stuff some kind of async Rust channel into this user data. And then on this completion context, I'm going to do absolutely nothing except call back on this Rust channel or send a message on this Rust channel to get us back into the original thread. So when we submit a packet in the Rust API, we're going to fill out this packet structure. In the user data, we're going to put a channel, just a very simple channel, like a single message channel, a one-shot channel in Rust terms, possibly. Or it could also be like a latch or some other kind of simple signaling operation between two threads. But we're going to send a message on this channel. We're going to put a channel sender into the packet, submit it to the client. Then on some other thread, we'll get this completion callback. We'll pull that channel sender out of the packet and then send that back, send a message on this packet, which probably just contains all this data all over again. We're not going to handle any of it. Just going to send it all back to the original thread. And then again, in our submission function, our future is going to wait on the receiver of that message. So the submit is going to send the packet off and return a future that just waits to hear back from that message. And that's pretty straightforward, very common pattern for dealing with this kind of off-thread stuff that happens in like another library. Just send it off to that library, get a callback on some mystery thread, and send a message back into the main thread. So let's go try to make that happen. And for now, we're going to be very sloppy, not sloppy, but we're not going to care too much about allocation performance. We're just going to allocate and free stuff as needed. In production quality code, we'd probably want to be caching things and not just allocating like crazy. But for now, we're going to do a lot of allocation. So let's go back and look at our previous code for dealing with packets. I think that's in main.rs. You can see here I boxed a packet. And all this stuff, I can just copy this. And also, since we're dealing with futures, I might not even need to box things. I might just be able to put them inside that future and use pointer. Might involve pinning, and pinning is something very complicated that I don't really understand. So for now, for simplicity, we're just going to box things onto the heap, take pointers to the heap. All right, so when we do an account lookup, we got to create a packet. Account lookup operation, we should probably put some data in that lookup operation. So this lookup operation, we'll say account. I'm just going to say account, U128. Eventually, we need to make sure our naming is like consistent with Tiger Beetle's naming and or Rust naming. And Tiger Beetle, I don't know if it calls this like an account or an account number or an account ID offhand, but for now I'm just going to call it an account. But Tiger Beetle accounts are 128-bit integers. This account lookup OK, I'm probably going to say like, I might even call this like, we're just going to do nothing with this for now. Let's see what the actual client implementation returns for a successful account lookup. Because a successful account lookup could be like, the request was successful and I found the account, or the request was successful and I did not find the account. And both of those are okay. They're both a success. So this account lookup operation contains our account. So here are our user data. I called it a null in this code, which is wrong. We need to, again, I'm going to take pointers to the heap for now, and we'll deal with the consequences of that down the road. Now, there might be much more efficient ways to deal with this, but I'm going to say let account equals box new. And inside that box, I'm going to put op.account. So now we just have a boxed pointer to point our user data at. For the account lookup operation, the user data is just a U128 that represents the account you're looking up. Other operations in Tiger Beetle have structs dedicated to them, but here it's just a 128. Looking at this, I'm wondering why oh, I got it. So I was saying we're going to put the account in the user data. That's wrong. We're going to put it in the data. User data is for our own custom purposes. So this data, I'm going to say this. I don't know exactly if I need to use all the same casting, so I'm just going to do it from scratch. And interestingly, this is a mutable pointer. The API, the underlying API, is expecting mutable pointers in a lot of places where I would not expect it. And I'm not sure if that's an artifact of how the bindings are generated, or just overlooked, or if truly the client expects to mutate this stuff. But this actually creates complications for us, because this, Rust doesn't want everything to be mutable by default. So I'm going to have to take a mutable pointer to this account. And to do that, I think I want to dereference the account. So the star account, I'm going to dereference the account. The comment is that mutating an account number seems like a horrible idea from a security perspective. So yeah, it does seem like if you sent off a request about an account, and it came back and suddenly it was a different account, if you're not expecting that, that's super crazy. So I'm suspecting that this is not actually going to be mutated by the client, that it's just some kind of artifact of how the CFFI is defined. Or maybe there are some cases where some operations mutate the request and some don't. The Tiger Beetle data types are defined to be very efficient. So sometimes it will do things that you might not expect if you're just trying to define something super clean. It might reuse a buffer or something. But I don't know if that's the case for these operations. I would expect the operations are immutable. All right, so I'm going to dereference this account. And then, so I'm going to dereference a box. This account is a box. And again, there's all kinds of casting that needs to go on here. So I'm going to dereference this account, which will give me a path to the account. The type is just account. Then I'm going to take a mutable reference to that. And now we should have, this whole thing should be a mutable Rust reference to a U128 instead of the original heap allocated box type. And then I can cast that to a mute U128, I think. Yeah, U128. And after that, the underlying type here for this data is not a U128. It's a C void, I think. Why don't we go confirm that under the tbclient.c or .h. tb packet t. Yeah, it's a void star pointer. Right, and the whole issue with immutability here is maybe, I'm not all that familiar with C, maybe this can't even be expressed as immutable in a C struct. So maybe it's just like inevitable. So this is a C void. So I cast it to as star mute C void. But even if that's the case, from a Rust perspective, like I don't want to just be passing it like immutable pointers to an API that's saying it needs mutable pointers. Because I might be wrong. So we got to do what the types say and create some mutable pointers here. All right, so I think that's the thing here. I think this is right. I already know C void is not imported though, so let's go import that. And what else do I want to do here now? I think I just want to type check this and make sure this all type checks. This batch allowed is, I have a 0 here, but this is a bool. Probably just another artifact of C not having a real bool type. Yeah, it says batch allowed is uint8. And so if I have this set to 0, then it won't even try to do any batching. But this is also, I'm just saying like, I'm not doing batching. And I've got our data size here. This is correct. I think I want to import, I think I want to go ahead and clean this up. I'm kind of annoyed at all the visual noise from these long standard library paths. So I'm going to go say use stud, mem, and pointer. And then next, again, I think we don't have any responsibility to do anything with next. Status, I assume that the client is going to set the status on callback, and we should probably initialize it to nothing. Although this, we might want to say, call it TB packet OK and use the actual enum here, because this status, you know, in C, it's just an integer, but it's actually a type in Zig, which corresponds to this TB packet status. So I think I want to say status TBC TB packet OK. And then this will change to something else if the client has some kind of problem with the submission. Lookup accounts, account lookup. Okay, I'm already seeing another naming problem. This operation says lookup accounts, but I called it account lookup. For now, I'm going to ignore that, I think. Let's see if this type checks. TB packet OK not found, probably because it's, oh, let's go look. Oh yeah, I'm looking at the C bindings here. The Rust bindings are probably going to give it a different name. TB status, TB, wait, this is a TB status? TB, oh. I use a TB packet status, but this is a status. Let's go look at the packet definition. This is a status. This is a packet status, okay. Another foot gun here of using these relatively untyped C definitions that I got. All these C enums look kind of the same from a type perspective. But this is not a status, this is a packet status. So in Rust, rs, TB status, I'll look for packet status. And the Rust bindings call this TB packet status, TB packet OK. That's a mouthful. TB packet status, TB packet OK. All right. That looks like the right thing. Now let's check out errors. Expected U8 found U32. Okay. Just another ugly artifact from the conversion between FFI. And implicitly returns something. Oh, my close method here. I'm just going to say okay. So right now, close always works. TB packet status, TB packet OK, include U8 as U32. Oh, I cast that wrong. U8. Okay, I'm going to commit that, but I don't want to do anything yet because, okay, first let's submit the packet. But the thing we need to do is think real hard about what this user data is going to be. But first, I'm going to just go ahead and call the submit function. TB packet. And again, I'm just going to crib off my previous code. Yeah, thank you, ThirdPies. You were right. I did that cast wrong. So on submit, we just call and TB, and this needs to be unsafe. TBC, TB client submit. That is self.client. Is this self.client? Yeah, I think so. There's multiple pointer indirections with the client pointer, so I'm just wondering if that needs a reference, but I don't think so. And then TB packet, and I can just call this packet. Okay, so that's a box, and I'm going to, thinking about the lifetime of that packet. I'm going to submit the packet, but not the box. I need a reference to that packet. I need to dereference that packet and get a reference out of it. TB client submit. Packet. This looks right. So this is a unsafe pointer to this packet. There's probably also a method I can call on this packet to get a pointer out of it or a reference to it, but I'm using the dereferencing syntax. I've kind of forgotten a lot of those utility Rust methods lately. I guess I just don't program enough in Rust lately to remember all those details. And again, this should work, or should compile, but this still needs to be a to-do because we're not done here. And this submit always succeeds. There's no return value here. We won't know if it worked until we get the callback. All right, that's still type check, so this is more or less correct. This box, we have to be careful not to deallocate this stuff, but this is going to return a future. So these boxes will all be trapped inside that future. Or at least that's what we want. We want those boxes to be carried, their lifetime, their ownership to be carried by whatever future we return here. But we've only passed unsafe pointers into the client. So have to be a little careful that these get captured by whatever future we create. I'm not going to return any futures yet because those futures are going to be built off of the channel we're going to create. This user data needs to be a channel. And on my other window, I'm going to go ahead and open up the client zig. Nope, not that. TB client.zig. And I'm going to need to keep looking at this completion callback. But before we write any more code, the thing I need to do is go do some internet browsing because I don't know what kind of channel we need offhand. So we're going to have to go do some research. And this is the first time we've had to go look at the interwebs on this stream. So that's great because going and reading the interwebs is pretty boring on stream. Let's see, okay. There's my OBS scene. And I think, so we can't use a regular channel from this Rust standard library because those are not for async contexts. We have to go find a channel that works with async. All right, in chat, Steel Tormentor is asking a question. Will someone from Tiger Beetle do the advent of code in Zig? If anybody should from Tiger Beetle should do the advent of code in Zig, it should be me because I don't know Zig very well at all. But whether I will do it, I'm gonna have to say no because I've never done the advent of code before, and I don't know. I have a hard time like dropping other work to do that kind of stuff, like retraining kind of work. I don't know if anybody from Tiger Beetle will do it. I'm wondering if you're thinking like do it on stream or what, because that could be pretty cool to have somebody from Tiger Beetle who are many people in Tiger Beetle are Zig experts. And they could like really go through and teach a few things on stream by running through the advent of code. You know, but honestly, I kind of doubt they would do it because the Tiger Beetle team is pretty small and there's quite a lot going on with, just getting Tiger Beetle out and supporting it in production and trying to make sure everything continues working. And I'm guessing most of them are not going to be having the time to do that kind of thing, especially streaming about it. Interesting question though. Now I'm kind of thinking about it, like, could I do the Zig advent of code on stream? But then even for myself, like this Rust client is like actual work that needs to get done for Tiger Beetle, and it's going very slowly. And so like doing anything else but this is probably just humoring my procrastination. I gotta not be a procrastinator and I gotta get this thing done. So I guess the answer, Steel Tormentor, about whether anybody from Tiger Beetle is going to do the advent of code is almost certainly not. There's too much other stuff to be doing. I do think there's tons of opportunities for Tiger Beetle people to be like teaching others publicly about Zig programming, because a lot of the Zig expertise in the world is concentrated in Tiger Beetle. And there's, MattClad does his streams, and that's great. MattClad's amazing. But we could do even more. He's only streaming once a week, and his streams are kind of explanatory. Like MattClad streams, he's kind of reviewing the code, but he's not writing code on stream. And somebody like MattClad, who is very smart and very skilled at communication and knows Zig quite well, it'd be pretty awesome to watch him stream kind of in the way I'm doing right now with Rust, but for Tiger Beetle or for Zig. And in the future, I will stream some Zig too. It's just this project is in Rust. Though when I stream Zig, it's going to be a disaster because I don't know Zig again. I mean, I kind of know a little Zig, but not much. Anyway, back to the topic. We got to go find some kind of async channel. So I'm going to go to docs.rs and look at the futures crate. I don't know if there's an async channel in here or not. I kind of think there isn't. I'm just going to search for channel. Oh, there is an asynchronous channel in the futures crate. Yeah, I have never done the advent of code chat. I don't think I have. I really think it's a very cool thing, and I know a lot of people who have done it and enjoyed it. My partner has done it a few times and liked it. I don't know, like when it comes to like learning by, when it comes to pure learning or like creating my own project, I'm always like, I just gotta want to go like make the thing I want to make. And it's very hard for me to like sit down and like read a book or do programming exercises and things like that, which I do think really hinders my learning process and has hindered my ability to learn over the years. Because I do it the hard way, right? I go write a project and, learn by poking at things, which has also got a lot of advantages, but kind of the hard way instead of going and just like reading and following instruction. I could learn so much more if I had just been more disciplined about doing things like advent of code. All right, enough procrastinating, Brian. Let's look at a channel. All right, this one-shot channel in the futures crate seems like exactly what we need. We just need to send like one message back to the original future. So I'm going to go ahead and open this tab. All right, we're going to have to do some switching back and forth between the code and the browser for a while. But let's go add the futures crate here. And again, I'm going to use the cargo add command. You can see futures has a bunch of features. Some of them are on by default. And then in here, I'm going to say, what do I want to do here? Let's go back and look at our types inside that documentation again. This is futures channel one shot. So it's a submodules here. And there's a function called channel. This will probably give us a tuple of a sender and a receiver. All right. I might need to name these types. Sender is in the one-shot module. All right, so I'm going to go import some stuff into our code. Say use futures channel one shot, and I'm going to import everything I think we're going to need. Channel, sender, receiver, I before E except after C. And run cargo check. Just habitually running cargo check. And again, we haven't run this code the entire stream, chat. We've just been running the type checker. And then here we need to create a channel and probably put the sender in a box. Because again, everything that we're gonna hand off to the client, we're boxing. That may not ultimately be necessary, but that's the easy thing to do that I know how to do offhand. So we're gonna say let sender and receiver, idiomatically in Rust, at least historically, we call these TX and RX, sender, receiver, equals channel. It'll give us two values, both ends of the channel. And then we're going to say let sender, we're going to put that onto the heap. I think that is what we want to do. And then I probably, right now what I'm thinking about, why I'm kind of going really slow, but my brain is spinning about whether we want to give ownership. Yeah, throat pies. The box is an easy way to just be confident about where that pointer is and where it lives, because we're going to be handing out unsafe pointers to other threads. And like, it might be possible to let the future own that pointer, but the heap, it's really easy to understand where that pointer really lives. It's, on the heap. It's out in space. But you could imagine like storing these all in the future and maybe having stable pointers to them. But I don't really understand futures enough offhand to know. And putting them on the heap is easy. Of course, we could put all these in one big box, but for now we're just creating 3 different allocations. So what I'm thinking about right now is this sender, we're putting it in a box, and we're going to hand an unsafe pointer to it in the user data. But I'm kind of thinking about who owns this sender, whether to let the other thread, the callback in the other thread own this sender, or just let the other thread see an unsafe pointer to the sender. And in Rust semantics, we really want to be like sending the sender to the other thread. So I might make the other thread responsible for deallocating this box. So to do that, I think I want to call, there's some unsafe method on the box that's just like, give me ownership of this via an unsafe pointer, I think. And that's what I want to do. So let's go back to the, web and go look up that box type in Rust. Stood Rust. maybe want to collapse. I was going to say collapse all of the, oh, there we go. This UI has changed recently and I forgot where to click, but this, in the Rust docs, everything is expanded by default and the docs tend to be pretty huge. So if you just collapse this, you can see a bunch of method signatures and not have to look at all the English writing. But we're looking for some kind of unsafe function. It might not even be an unsafe function, but it's a function that gives us kind of an unsafe pointer and takes ownership of the box. Because this box implies ownership in Rust and will be responsible for destructing the box. But we don't want to do that. We want to pass this box unsafely across threads and have the other thread kind of take that unsafe pointer, convert it back to a box, and then be responsible for destroying the box. Okay, here's into slice into inner. I don't think that's it. And one thing we do here is just take an unsafe pointer and then call forget on the box and tell the Rust type system to forget about destroying the box. But I feel like there is some kind of method specifically for this purpose, but I could be wrong. Slice, no, that can't be it. That can't be it. That's probably not it. Any of these return into raw sounds like the thing. And then there's a from raw. This is from raw in, but there's probably a from raw as well. So this is what we want. Take this owned box and just convert it to an unsafe pointer. And then on the other side of the thread boundary, we'll say from raw and turn the unsafe pointer back into a box, at which point it'll get destroyed properly. So this user data, we're going to say tx.into raw, and that's going to give us a unsafe pointer to a t, which in this case is the sender, but we're going to say as star, what is this type supposed to be? Let's look at packet again. User data, any opaque. Let's go look at the FFI bindings instead. TB packet user data is a mutable void pointer. As c void, as star mute c void. Okay, so now this user data is just there. Now we got to be careful here because now this box, the sender is no longer owned by anything. So if there's like a panic in between here and there, then we're just going to lose it and it's going to leak. So we've got to be a little careful about that. But I don't really see an opportunity to panic here. Okay, then down here, so here we got the mutex has been, or the channel sender has been passed off to another thread. Let's get this to compile. Associative function, not a method. This error is just saying this method here into raw, for whatever reason, it's not actually a method, it's a function, and you have to pass in the self type. I'll show you that on the, oh, chat, I've been showing you the wrong window. Anyway, let's go back to the window. Into raw takes a box, but it's not a self type. Like this is just a function that takes a box. And the reason for this is almost certainly to avoid confusion with automatic dereferencing in Rust. Like this could just as easily be defined to take self box, but it's not. All right, this time let's correctly go back to the code. And here we have to call, because it's not actually a method, we call box into raw and then pass tx. Let's get that to build. Okay, our channel thing can't infer the types, can't infer the types here. So we're going to say this is a channel of, what is this a channel of? That's a good question. Ultimately, this is probably going to be a channel of all the things that are passed into this callback here. One thing to really wonder about here is who owns this result pointer, because the TB client is going to be calling back this result pointer, and this is not something that I have allocated. So this must be allocated internally to the TB client. And so if that's the case, it's probably expecting by the time this completion succeeds, this result pointer, we will no longer be holding pointers to it. So we can't just blindly pass this result pointer back to the other thread, because by the time the other thread sees it, the TB client will have recycled it or freed it or something, and it won't be valid anymore. But this packet presumably is completely owned by us, and so we can just pass the entire packet back. So what I want to do is down here on completion, I want to find another struct called completion message. And this is going to contain like the equivalent of everything in this completion callback. We're going to call it context is a usize. Client is TB client T. Packet is a mutable TB packet T pointer. Timestamp is a U64. And this result pointer, our callback is going to have to copy out this result pointer. That's unfortunate. And just because, it's a copy into another allocation. But that's what we got to do for now, at least. So we're going to say result is a vec of U8. And that's going to be a copy of whatever this result was. So now the answer to that question that the compiler proposed us about what is the type of this channel is that it's a completion message. So this is a channel of completion message. Let's see if that builds. TB client isn't imported at line 99. TBC, TB client, and TB packet T, also in the TBC namespace module. Okay, that all builds. All right, it's 5:11 now, and Chad, I've promised my partner we would go out and get a drink and some dinner. Not urgent yet, but you got to keep an eye on that clock. I was really hoping to get through this today. All right, so we've got our box. We've sent the box into the packet. We've submitted the packet. Now we have our receiver here. And we can say, or remember, there's all an async function. So that receiver we can receive on. And we got to go back and look at our API for this async receiver because I don't offhand know how it works. Okay, so this, we don't need our box docs anymore. We have a receiver. And we call try receive on it. It's an async receiver, right? This doesn't look async. Oh, attempts to receive. Okay, this is non-blocking. That's why. That's not what we want. We don't care about that. We want something that returns a future. Here's a future. Close. Does not schedule just attempts to receive a message outside the context of a task. Oh, the receiver itself is a future. Okay, interesting. So there's no method to call on the receiver to get the value. You just await the receiver. The receiver is the future of T. That makes a lot of sense. Because it's a one shot. You can only send one message over this channel. It's not a stream of messages. So then we can say let message equals, it's been a while since I've done Rust async await. We're going to say the receiver dot await. And can this return any kind of error? Surely it can return an error. Let's go back, look at those docs one more time. This is a receiver. This must be a future of result of T. Let's go. So the try result can return a result, or the try receive can return a result. Let's look at implement of future here. So receiver itself is a future. And you can see here, it's a future of a result of either the thing you're looking for or canceled. That makes a lot of sense. So let's go back to our code again. And I'm going to go ahead and import canceled. I think we're going to need that. So here we can say rx.await, and this is a result still, and we can return a result here. So we can call a dot question mark on it, but this won't automatically convert. Oh yeah, it will, I think. I think this will automatically convert to the anyhow error. Okay, so this await, this is a result of our message. What did we call it? A completion message or canceled. This is not our message yet. We need our message. And to get that, we can use all kinds of ways to get that message. We can call message dot question mark. And this question mark, is it dot question mark? I think it's just question mark in Rust. I think it's message question mark. And that'll kind of unwrap the result or propagate it upward to our error. And my big question is whether this question mark will automatically do the conversion or not for the particular error type we're using, the anyhow error. And I think it will. Let's confirm that. Again, we're using a very simple error type for prototyping, but eventually we're going to have to use a more type correct error type. Okay, so we don't actually need to type all that out. We just say await question mark. All right, now we have our message. And again, this is, what do they call it? It's a wait point. The future is going to suspend here, a suspend point right here. This await is going to be like, we're just going to return this future to the caller, and when this future is waited on, this will actually continue execution here. So everything up here is going to be captured in this future, including these boxes that we own and someday need to free. I think all that makes sense so far. So then we have a completion thing, and then we have to do something with the completed packet. Right now I'm going to look at our completion message. We have our packet. We have our completion context. This is what we're getting back. And we need to handle this in order to return some kind of account lookup OK or an error. So how do we handle this message? I think the first thing to do, and again, we're not going to need to look at these at all, is timestamp right now we don't care about. This result we will care about. But there's like multiple things that could go wrong with this submission of a packet. And first of all, we need to look at packet tbc client.rs. This status is going to be filled in by the client. And if the status is not okay, then everything else is probably wrong. Like nothing else is going to matter. There's no more handling to do if this status is wrong. So let's say if message dot, and this is probably going to be a lot of unsafe under here. So let's just assume it's tons of unsafety. If don't need parens around the expression head in Rust. Always forgetting that. Message dot packet. All right, I have so many things I need to see on screen right now. Our completion message packet. All right, message dot packet dot status does not equal probably tb packet status tb packet okay. tb packet status tb packet okay. Then we need to do some error handling. This is the good case here. And we can just do an early return here. So this is the good case here. So if it's not okay, errors all around. And we're going to return error. And again, for now, we're just going to use really simple errors. Packet status and just print message.packet.status. And again, this is not sufficient for production code, but when we change the error type, all the cascading compile failures will force us to go reevaluate this branch and make it more useful. But for now, if it's not a good packet status, it's, here's an error message that says some packet status. Real quickly, I'm curious what these packet statuses are. All right, too much data. Client evicted, client shut down, client evicted. What does that mean? Client shut down, invalid operation, invalid data size. Okay, that's all interesting. Client shutdown is interesting because that's not really, that might be something that we need to handle internally. Like if the caller closes the Rust client, then there's kind of like a race there between submitting the packet and handling the packet result and shutting down the client. So if we see this client shut down, that's probably okay. We intentionally shut down the client. We'll have to see whether this shows up in practice and whether we need to handle this. This might be like an exceptional case here where if it's client shut down, then maybe assert that we intended to shut down the client or something like that, but don't propagate it back to the user. All right, I see chat. I see you, chat. There's stuff going on. Let me take a drink before I read what's going on in chat. All right, Throat Pies says he just unwrap or else if you didn't know about the error. TB packet status, TBC, TB-PAL. Thank you, Throat Pies. Wow, you're paying attention. All right, so he's noticing. They are noticing that my I did not qualify this with the correct module here. Like a compiler in your brain, huh? I have so many other errors here. All right, let's figure out all these errors now. Unknown field inside of, okay. This is a raw pointer and you can't just reference directly into the field into a raw pointer with a dot operator. You gotta dereference the raw pointer first. And the compiler is just gonna tell us the correct thing to do, which is super nice. So we're gonna dereference that packet and then follow the dot operator into the field of the unsafe packet. Okay, and again, more weird casting required here because of the just bindings are not quite perfectly have perfect fidelity with the underlying types. There's several layers of translation. So the bindings say that this is a U32, but the API, this field, is a U8. Probably just because the bindings either don't know how to tell C what underlying representation to use for enums, or that maybe that's just not possible in C. Let's look again. So we got to do some just more casting around. As U8 here. And again, there's a problem here with our accessing a field of an unsafe pointer struct. Gonna dereference that pointer first. And one more, it's looking for a result of account lookup error and found nil. Why is that? Oh, yeah. Because down here we have more cases that we haven't filled out yet. So this is just dropping off the end of the function without returning anything. Okay. So that's our first error case, is that, you know, maybe the packet wasn't handled correctly. And then now we have to take this result vector that we have and convert it to the proper result type and inspect that result type. And I'm very curious. We might need to do some like running the code and figuring out what that result is supposed to be. So again, in the packet, when we get the packet back, there's some kind of pointer. Oh, sorry, it's not there. It's, where is it? TB client. Yeah, this completion, a result pointer. This is some kind of buffer that is operation specific. And what I am imagining the client does for the account lookup operation is it gives us a U128. And if it found the account, it's going to give us that account ID. And if it didn't find the account, it's going to fill that U128 with a 0. And I'm hoping a 0 is like reserved invalid account in Tiger Beetle. Like something in my memory is telling me that that's the case, but I don't know. But for now, I'm going to write the code as if that is the case. And then when we actually finally eventually run the code, we'll interrogate it and figure out if that's what's actually going on. So now I got to cast the contents of this buffer. So we'll make an assertion about this buffer first. Actually, let's take a pointer to it because we don't want to keep dealing with this dereferencing situation. Oh, it's already in the message. So we can say assert. I want to assert something about the length of this buffer. Message dot result dot len, and we call this assert eq, is mem size of U128. And then we want to convert this buffer to a U128. And we're going to do it the rusty way. Inside of Tiger Beetle very values efficiency, right? So inside of Tiger Beetle, there's all kinds of just unsafe casts, from buffers to structures and buffers to plain old data types, which makes me, as a Rust person, makes me very uncomfortable because I'm like thinking like, what about Indianness here? But as far as I can tell, Tiger Beetle just assumes everybody's little Indian, which is completely fair, especially in Tiger Beetle's domain where you're going to be only people running on specific servers are going to be running the code. But from a Rust perspective, I think like just casting buffers to structs seems crazy. But we need to remember how to cast a buffer to a U128 in Rust. So let's go back to the let's go back to the Rust documentation and refresh our memory. And I think what we want to do is look at, just search for the word LE for little endian. Oh, that's also less than or equal. That's not helpful. Let's look for BE. There's a 128 2BE. And I'm not sure if these are what we're going to want or not. But here's like a 2LE. And there's probably I saw there's a 2LE bytes or something. Let's look down here through the methods. We want from LE bytes. Sounds very promising. So here we have 16 bytes in a slice of U8s to give us a U128. That sounds like exactly what we need. So this should be a foolproof way and type safe for the most part. I mean, no, I don't know what I want to say. There's no undefined behavior involved in just casting from bytes to U128. Oh, actually, there could be. The alignment could be wrong of your buffer. So if you have a buffer of 16 bytes, and you just do a pointer cast from a pointer to a byte buffer to a pointer of U128, your byte buffer could be aligned incorrectly. Your byte buffer is going to have like a minimum byte alignment, and your U128 probably has a 16 byte alignment. So if your byte buffer doesn't begin on a 16 byte boundary, then you've just created undefined behavior, probably. Depends on the architecture. Oh, from a compiler perspective, it's probably always undefined behavior. But this method is foolproof. It'll just work. So we're going to say, let's go back. Remember this method name, from LE bytes on U128. So we can say, let account equals U128. We're going to say not let account result. I'm going to say let result equals U128 from LE bytes. And this is going to be message.result. And we need to take a reference to that result, and that'll be coerced to a slice by Rust. And that should be the whole thing. And here we can go ahead and encode our logic and say, based on what I said before about how we assume this API works, we're going to take this account lookup K and enum, and we're going to say it can either be found or not found. And we might as well derive EQ and partial EQ. Partial EQ. And then we'll say if result equals 0, then it's not found. We'll do the positive case first. If result does not equal 0, we're going to return OK of account lookup OK found, else not found. And based on our assumption that a 0 valued account is not valid, let's go up here and say assert ne op.account 0. And this assumption may be incorrect. This may not actually be how the result is used, but we'll find out another day probably, because I'm really running out of steam here. All right, our error is expected. Oh, it doesn't expect us. Oh, this is gross. Okay. This from LE bytes is not expecting a slice. It's expecting a 16-element array. All right, so there's some Rust API somewhere in the standard library that's going to help us convert from a slice to a 16-element array. But I don't know what it is offhand. Let's go poke around the doc some more. It's kind of tough too. We might just go ask ChatGPT to tell us, because kind of tough to search for 16-byte array methods in the standard library. In Rust, how do I convert from a slice of bytes to a, let's see if it just understands the syntax, U816. Let's see if it figures that out. Seems like it understands it. Oh, you can just use try into. Is that correct? Can I just try into that? That's so easy. Let's see. I was expecting it was going to be some kind of a dedicated method. But oftentimes in the Rust standard library, like try into is the generic conversion type that is applicable to almost any two pairs of types. So there's often like an underlying conversion that is more type specific that try into delegates to. And oftentimes it'll be easier to read the more specific method, because try into, because both types involved are generic, it offers offers no visual clues about the things you're converting between. So a lot harder to read try into. But if you've just got two type inferred types, like it's very convenient to just say, yeah, just convert it, figure it out and convert it. But let's see. So the thing that didn't work is this. This is supposed to be an array. Let's say bytes equals, and this should be type inferred because this is a concrete type in this method, this argument. Message dot result dot try into dot expect U128 bytes. So this, if the underlying client is coded correctly and my bindings are coded correctly, and my assumption about how this result pointer works is correct, this will always succeed. So I'm putting expect here and not handling any errors. Let's see if that builds. Oh, yeah. So you want to convert in Rust from a slice of unknown length to an array of known length. You can just call try into, just like any other conversion. Now I know. I'll definitely forget that shortly, though. And that probably only works for arrays of up to a certain length because of numeric generics or whatever they're called. But maybe that's been fixed recently. That all seems correct-ish. So now we've written all of the client-side thread code. We submit we put a channel into our user data and then receive on that channel. And then our message, we're going to get all the results from this completion callback in our method, in our message. We handle the status for the submission. And then we look at the result of the operation and handle the result of the operation. This looks correct. So now we're missing the other side of this thread. In our completion callback, we have nothing yet. I'm going to keep this print line here just to help us for debugging later, because again, we haven't run any code in the last 2.5 hours we've been working on this project. We've just type checked. And we're not going to run any code today at all, I'm afraid. It's just, I am fading. But let's see if we can do a little more here. So on completion, we get the client. And I think I got to split another window here because let's split it over here. I need to look at several things at once. We have our completion method message. So we have to convert all these arguments, completion arguments, into a completion message and then send them back. So the first thing I want to do is I want to grab that channel out of the packet and rebox it. Because if you recall, what we did here is we made a box of the channel sender, and then we converted that box, that owned box, into an unowned, unsafe pointer to pass it across the thread boundary to this callback. So this callback, it's one of its big responsibilities is making sure it handles the correct destruction of that channel sender. So I'm going to say let tx equals box from raw packet dot user data. And this packet user data is again a unsafe pointer to a C void. So we need to cast it back to the correct thing. And this is a star mute sender of channel message. I think that's right. And so now this will be dropped as needed at the end of the completion. And let's go ahead and write a 0 into this pointer that we just pulled it out of, just for thoroughness, so nobody else can ever look at that pointer. Packet.userData, and I think we need to dereference that. Nope. Packet.userData equals pointer null mute, I believe. And now we need to build this completion message and send it back on that channel. Oh, first, before we do that, let's take this result pointer. And again, our hypothesis is this result pointer is owned by the client and that we must use this result pointer by the end of this completion. That's the only thing I can think that makes sense here. Once this completion returns, the client is going to either free this pointer or throw it back into a cache or something. So we got to use this pointer. We got to use anything out of this pointer before we finish this method. So in order to send it back to another thread, we got to copy this into a vector. So we're going to say let result equals vec. Not exactly sure how I want to do this. Slice from raw parts of, interesting, this is a const pointer. So many of the things we've looked at so far have been mutable pointers, but this one's a const pointer. Like even we've hypothesized that those mutable pointers aren't going to be mutated. We've still seen a lot of mutable pointers, but this one's a const pointer. From raw parts, result pointer, result len, and that is a U32, and I already know it needs to actually be a U size for Rust. So now we have a slice of this memory, but we need to copy that slice into a vector. So I'm going to say let result equals vec from slice, maybe? That'll probably work. And now we got our sender, our message sender, and now we've got our result. And now we can build our completion message. And again, in our completion message, we have our packet. So the ownership of this packet, it's interesting. The original submission function owns this packet. And from a Rust perspective, we have continued to hold a box to this packet. While also handing a mutable pointer to this packet to the client. And if that client actually mutates this packet while Rust thinks it's not allowed to mutate that packet, we have caused undefined behavior. So really what I think we need to do here, probably for everything, is just release ownership of these boxes from the Rust side, pass them to the client, and then when we get these back from the completion callback, reclaim ownership of these boxes, because otherwise Rust thinks we own these things and they can't be mutated. I think that's what we have to do, actually. I might make this a fix me now, though. Give ownership of these boxes. I'm thinking about whether I actually want to make this a fix me or just fix it. Well, the thing is, ThroatPies is saying in chat, like, you know, better to do this than fight the borrow checker. But the borrow checker is not going to come into play here because on the Rust side, we're dealing with ownership, but we've taken unsafe pointers and given those to the C side. So the Rust side doesn't even understand what's going on with those pointers anymore. And the borrow checker is not going to have any insight into those pointers. So from the borrow checker's perspective, like, this stuff is immutable. There's no pointers to this stuff and it's an immutable. And I think it'll be a mistake if we hold on to these boxes. I think we have to give these boxes to TB client and then reconstruct them later. I'd be very curious for someone with more expertise than me. Though this is like one of the very tricky things about writing unsafe code in Rust. Like, you got to think about that kind of stuff. And I was about to not think about that. And it seems like it was going to be a mistake. And there's so many sources of undefined behavior when you're dealing with FFI boundaries in Rust. So this account, like we called box into raw here, this account, I'm also going to say box into raw for this account. And then this packet, I'm going to do the same thing. I'm going to say, I'm going to have to write some docs here explaining like who owns all this stuff and who frees it. And in fact, I can probably, all right, I'm going to do a bunch of things at once here. This is probably a mistake, but I'm going to put this in another scope here. And this stuff, I'm not going to let this stuff leave this scope. And I think that'll do it. So this makes it very clear that ownership of this stuff is not going to leave this scope. All right, so transmitter, we've unboxed or put it into a raw. We've forgotten it and sent it out into the void. An account, we've done the same. So now Rust knows nothing about these pointers anymore. That looks about right to me, but then we have to do the same thing for this packet down here, and we got to say box into raw packet. And then back down here, we got to do the opposite. We got to reclaim all those things. So here I'm going to say let packet equals box from raw message.packet, and then this stuff is not relevant anymore. And now we own this packet again and we'll free it correctly. Get rid of all these. This helps. We get rid of this, all these unsafety references. That's nice. Packet. And again, I'm going to overwrite that pointer with a null pointer just to make sure. Message.packet equals pointer null mute. Just put a 0 there. And then the same thing for that, what was it? This account. This is also an allocation. This data, I'm gonna pull that out as well. Let account equals box from raw packet dot data. And we have to cast this data to the correct type as star mute U128. A lot of unsafe code here. This is getting pretty tricky. U128. And then again, I'm going to overwrite that pointer just to make sure nobody touches it. Because at this point, Rust sees that as an owner, and we don't want to mutate it through the unsafe pointer anymore. Packet.data equals pointer null mute. Oh, packet.data. Yeah, that's it. Count. Okay, now that'll be freed correctly, and we should probably go type check something because I've written a lot of code here. Channel message not found. 45. Not channel message. This is completion message. Slice 148. Didn't import slice. Cannot assign to message packet as message is not declared as mutable. Okay. Message.packet. Interesting. Kind of wondering whether I want to mutate that message now or not. You just drop that message at this point. Do I use it anywhere else? Yeah, I do. Okay. Okay, so Rust won't let me do this because message is not mutable, but I really want to do that. So I could like destructure that message and throw away that package pointer. Do I want to do that? It's getting complicated. I think I'm going to just make the message mutable and keep doing that, but it's pretty ugly. It might be nicer to just destructure this message and then forget this pointer instead of overwriting that pointer. Let's make it mutable for now, and then we'll come back in a second and try it both ways. Let's go ahead and fix all of these errors first. Cannot assign because packet's not mutable. Yep. Yeah, it's interesting. This packet, should I just destructure this packet then? Maybe I'm just wrong-headed in even trying to... Maybe I'm just wrong-headed about assigning these. Because these are immutable pointers, so I can't write to these unsafe pointers. Or can I? Yeah, I can. I'm just going to comment this stuff out for now, and we'll think about it some other time. We need to get finished up here. User data unknown field 145 from raw user data packet.user data. Really? That's unknown. Let's go look at our packet again. Wait, maybe it told us. Yeah, okay, it told us. We need to dereference that unsafe pointer. This one, the other one. Oh, both of them. Oh, all right, chat. This is very interesting, actually. the pattern that I was just trying to do that Rust stopped me to do is actually totally unsound. So what I did here, no, it's fine. It's fine. I was thinking that I converted it to an own type, immutable type in Rust and then assigned to it. That's not what I did here. That's not what I did here. I just rewrote this pointer. I converted this pointer to a box and then rewrote the pointer. So this seems okay. From slice, not found in vec. That's really, how do you convert from a slice to a vec in Rust? This is something I feel like I should know. Let's try from. From seems like it. Call to unsafe function. Okay, did a lot of unsafe stuff here. Okay, that all type checks. Let's check that in. And the only thing we haven't written left is whatever this to do is, which seems straightforward. I think all we have to do is say tx.send. And we might need to go look at the API for this particular channel we're using one more time to see how you send with it. Okay, remember that we're using these one-shot channels from the futures crate. We have a sender here, and you just call send on it, which consumes the channel, the sender, and it may fail. And if it fails, it returns the thing back to you. It's possible for this to fail. An interesting question here. If this fails, who is responsible for freeing the resources? Because right now we're expecting that we're going to send these resources back to the other thread, and that thread is going to convert these unsafe allocations, these pointers to Rust allocations back to boxes, and then they will be freed. But if that future in the other thread has disappeared or is never awaited, then nobody will ever receive this message. Okay, there's some considerations here. This is actually kind of tough, because the send could fail, in which case the other future has been destroyed. And if the send fails, we can do some cleanup here. But if the send succeeds, but the other thread never awaits, then these unsafe pointers are just floating in the ether, never to be seen again. That is tough. Maybe what has to happen is this completion thread has got to convert these things back to the proper types. Okay, that's gross. This is very gross. Yeah, sending unsafe pointers that nobody owned over a channel means those unsafe pointers could just disappear and never get freed. So what I need to do instead, I might need to sleep on this. I'm really getting kind of frazzled, having a hard time concentrating at this point. So what has to happen, or what I think is going to have to happen, is this completion. This completion is responsible for converting these unsafe pointers back to Rust boxes. then we're also assuming that the client does call these completion callbacks. There's no situation where the client fails to call the completion callbacks. I believe that is true, because if the client didn't call these completion callbacks, then we have given it Rust-owned pointers that never get freed. But I believe the client will always call this completion. But we can't just send these unsafe pointers with no Rust owner back across the channel to the other thread, because that channel may not ever be read. So the thing to do here is to probably convert all the unsafe stuff inside this packet back to Rust boxes right here on this thread, and then send them. Because then if those channels on the other side are never read, when the channels are dropped, the Rust allocations will be dropped. But to do that conversion, we have some options. Like, the types involved in this packet are dependent on the operation. And I kind of don't want to put like a switch on the operation here and have the operation-specific logic split between the submit methods and the completion method. So what I'm thinking in my very tired brain right now is that we will also throw a closure into that user data to let the submit method deal with that completion callback itself. So instead of sending that raw data back in the completion, we will write a completion method right here, like a completion closure. And we'll call the completion closure in the completion method, in the completion callback. And then this closure can be responsible for doing the operation-specific conversions. But I need to think about that more, and this is getting a little... It's time to go wrap this up and have dinner. But let's real quick commit what we got, push what we got, and go see what chat's doing. Look how great my background looks now. So the window next to me is no longer shining sunlight in, and everything looks very lovely right here. Beautiful. I can also do this, which looks okay. I'm forgetting how to cycle my colors. Oh, that's a pretty good one. Anyway, it's time to go have some dinner soon. Midnight Simon Son asked if we're programming a kernel, and thanks for the comment about the color, Throat Pies. Yeah, I've just started streaming recently, and I'm pretty happy with my setup. I do like when it's dark outside and the sun isn't making everything look washed out. I do like having like a kind of purple, pink, kind of like a cyberpunk synthwave background going on here. Midnight Simon Son asks if we're programming a kernel. No, we're not programming a kernel in this stream. We're writing a Rust client for the Tiger Beetle database. And I'm going to be writing this Rust client for probably weeks to come. I don't have a regular schedule here. I'm just kind of streaming when I do work, though I might commit at some point to like a particular time every week to come by to have some kind of regular schedule. But at the moment, I'm kind of streaming here and there whenever I am ready to come hack. But I'll be around doing this same thing for weeks to come. So if you had a good time hanging out tonight, I really hope you come back, because this has been a great experience for me. Throat Pies asks, is the client binding open source? Yes. Almost everything in Tiger Beetle is open source, and this will be in the main Tiger Beetle repo. All the Tiger Beetle clients are in the main Tiger Beetle repo. Right now, this is just in my fork, but it will be open source. In fact, I said almost everything in Tiger Beetle is open, and I don't specifically know of anything that is closed right now, but there definitely will be at some point. Yeah, so I'm just watching myself on video right now on delay as I get ready to shut this all down. I think there is probably not much else we need to do here. Next time we will probably continue along these lines and actually execute this code and get the resource deallocation correct for that situation we just explored in the completion callback. Then we'll run the code and make sure this account lookup call works correctly. And once we got this pattern working correctly for the account lookup query or Tiger Beetle operation, we'll just have like we'll be able to duplicate this pattern for all the other operations, and we'll kind of be home free. I'm sure there'll be a lot of details, but once we have one query looking, the other ones will come pretty fast, I think. And then we'll just kind of be on the path to like figuring out how to polish this up and make it available for other people, submit a pull request, check it in, and let other people try this out. But it's all looking pretty great now. I'm pretty excited for what's next. I think I'll be back tomorrow, so I'll see you all. Steel Mentor, thanks for the kind words. I really appreciate that. It helps a lot. Oh, thank you also, Throat Pies. This is very, very taxing and though so far very rewarding. So I'm very grateful for everybody who's come in and enjoyed what we're doing and supported me, and I hope to see you again next time. All right. See y'all.